buzz going around that on April 29th, the world is going to end, as an asteroid as big as the Himalayas is going to hit the planet. The asteroid, named 1998 OR2, is estimated to be 4 kilometers in diameter. At the higher end of that estimate, it suggests the space rock could be around half the size of Mount Everest. It's set to pass Earth on April 29th, at which point it will be 3.9 million miles from our planet. While that might sound far away, it's classed as a close approach by NASA. Let's make it absolutely clear that there's no chance of a collision between this asteroid and Earth. At its closest approach, the asteroid will be 3.9 million miles from Earth. That's more than 16 times the average distance between Earth and the Moon. NASA has classified that asteroid 1998 OR2 as potentially hazardous, not because it puts Earth in danger, but because it fulfills certain criteria in the agency's classification scheme. According to NASA, an asteroid qualifies as potentially hazardous if its orbit ever intersects Earth's orbit at a distance less than 4.6 million miles, or 0.05 astronomical units. 1 astronomical unit is the distance between Earth and the Sun. Before we continue further, be sure to subscribe to the channel, that way you won't miss any of our weekly videos. What are the chances of this asteroid hitting Earth? Asteroid 1998 OR2 is over 4 kilometers wide. Any asteroid that spans more than 1 kilometer in diameter cannot be compared to any human-made weapon. If it were to hit Earth, it might not destroy all life on Earth, but the resulting impact would be 10 times worse than the damage from Hiroshima. If it were to hit land, the asteroid would throw up enough dust and debris to block out the sun. If the sun is blocked, no sunlight can reach the Earth. Without sunlight, the temperature will drop significantly, and Earth will move into an ice age. Depending upon the length of time, all life on the Earth will cease to exist. The asteroid crashing into the water would result in numerous tidal waves hundreds of feet high, capable of submerging entire coastlines. Smaller asteroids called comets or meteoroids breach Earth's defenses fairly often. However, large objects that pose a threat to life are rare. A historical study of asteroid strikes shows that a kilometer-wide asteroid hits the planet every 500,000 years on average. But asteroids bigger than 5 kilometers only come around every 20 million years. There is a real but very small risk that we will be wiped out by the impact of an asteroid or comet, says the study published in the Journal of Evolution and Technology. There have been at least 5 confirmed mass extinctions, and at least 1 is directly attributed to an asteroid hitting Earth. The KT extinction, which wiped out the dinosaurs 65 million years ago, is believed to be the result of an asteroid at least 10 kilometers wide hitting the Yucatan Peninsula. In order to track the threat posed by an asteroid, NASA and the European Space Agency are continually monitoring space for all approaching bodies. They're also working on potential solutions to either destroy or reroute an asteroid, if one is ever heading directly for the planet. It's a statistical certainty that one day the Earth will get hit by a large asteroid, whether that's in 50 years or 100 million years. Are we prepared to stop an asteroid from hitting the Earth? Protecting Earth from incoming asteroids will be a huge job, but don't expect astronauts to do it. It would all be done by a robotic spacecraft. The simplest method is a kind of planetary billiards. We can use a space probe to send a heavy object or the probe itself, and smash it into the asteroid. The asteroid will then, hopefully, be pushed off the trajectory and miss the Earth. A joint European Space Agency and NASA mission will test such technology in the next few years. The mission consists of 2 spacecraft, one called the Asteroid Impact Mission or AIM, which will launch in late 2020, and the second, the Double Asteroid Redirection Tester DART, which will launch in 2021. In 2022, they'll arrive at a double asteroid called Didymos and Didymoon. Didymos measures some 780 meters across, while Didymoon is about 170 meters wide. The AIM craft will follow the asteroid and study its composition. Once DART arrives, it will crash into Didymoon, and AIM will see what the effect on the smaller rock's orbit is. The idea is to find out exactly how much one can move an asteroid without running the risk of sending it on a dangerous trajectory, a kind of baby step to actually redirecting it.